Hello guys, welcome to SheCode. So in our top 100 code series, the next problem 25 is for conversion of binary number to decimal number. Again, this problem is very important from the point of view of your placements, interviews or any exam. Okay, so before starting with the conversion, let's understand what is binary number system and what is decimal number system. So a binary number system is a number system where we represent the numbers using only two digits, that is 0 and 1. And in decimal number system we represent numbers using digits from 0 to 9. Okay, we can calculate a decimal number from binary by multiplying every digit of binary number with the 2 to the power starting from 0 to n minus 1. And what n is over here? N is the total number of digits present in binary number. To multiplication we have to add them all. Okay, so what I just said, let's understand through an example. Okay, so in the left side you can see a table where we have decimal numbers and binary numbers. So what exactly the number is represented in binary has been written in the decimal form also. Like 0 is represented as 000 in binary. We can represent 1 as 0001 in binary, 2, 3, 4, 5, like this. All the conversion and the values have been given. But what if the number is greater than these 4 digits or 5 digit numbers in binary? So what we have to do is, as I said in the definition, that we can calculate a decimal number by multiplying every digit of binary number with 2 to the power of 0 to n minus 1. Okay, as you can see over here in this example, we have a binary number 1010 and 10. Now we have to convert this number into decimal number. So what we have to do is, we have to multiply every digit of the binary number with 2 to the power of 0 to n minus 1. Okay, so here the indexing is from 0 to n minus 1. If this digit is of like this number is of 6 digit, then the indexing will be from 0 to 5. So this the rightmost digit will be of index 0, then 1, then 2, then 3, then 4 and then 5. What we have to do is, we have to multiply every digit with 2 to the power of that index of the number. Okay, so if we start from 0, that is the rightmost digit of binary number 0, then we have to multiply 0 with 2 to the power 0, and here 0 is the index of that binary number. Okay, now we will multiply 1 with 2 to the power 1, and then we will multiply the third number which is at index 2 with 2 to the power 2. Okay, so this is, we are going to multiply every number and then at the end we will add them all. Okay, as you can see that 0 into any number is 0, then here we have 0. So 0 into 0 is 1 into 0, which is 0, and 2 to the power 1 into 1 is equal to 2 into 1, then 2 to the power 2 is 4, but it is multiplied with 0, we get 0, then 2 to the power 3 is 8, 8 into 1 is 8, 2 to the power 4 is 16, but it is multiplied with 0, then we have 0, and 2 to the power 5 is 32 into 1, which is equal to 32, and then we add these numbers, we get 42. So when this binary number can be written as 42 in decimal number system. So let's start with the coding portion. Okay, so let's start with the code. I have taken two variables, binary and decimal. The binary will be our binary number, and decimal will be our converted decimal number. Decimal variable has an initial value 0. Using a while loop. While loop will run until the value of binary is 0. Okay. Now, as I discussed in the previous portion of this video, in the example portion, that what we have to do is we have to multiply every digit of binary number with 2. Okay, so let's focus on that multiplying every digit. Okay, so to separate every digit from a number, we divide the number by 10. Okay, and this is the most obvious thing. We have been discussing this thing in every video, in almost every video. If you haven't seen the playlist, haven't seen a video on sum of digits, palindrome number or an Armstrong number, then you should go and check out the description for the links, where we have discussed this separation of every digit from a number in detail. Okay, so I am taking a variable temp over here, which will store my digits. Okay, it will store the binary digit. So to separate every digit from the number, we divide the number by 10. Okay, so this operator, this modulo operator will give us the remainder, and that remainder will be the last digit of that number. Now, the next step is to multiply that number with the 2 to the power of 0 to n minus 1. Okay, so let's take another variable n, which is a power and whose initial value is 0. Okay, as I discussed that the binary number, the last digit of the number from right hand side has the index 0. Okay, if we talk in the terms of indexing, then it has an index 0, then 1, then 2, and then 3, and then 4. So we will take initial value of n to be 0. To do is we have to multiply that every digit. So temp into math dot pow और इसमें and in this the base will be 2 and then the power will be n, and where we are going to store this, we are going to store this in decimal variable, and it will be and this decimal value will be keep incrementing whenever this loop is running. Okay, whenever the condition is true and this loop is running, the value of decimal will be keep incrementing product. Okay, so now as initial value of 0 and n is 0, so what we have to do is we have to keep adding, keep incrementing this value as the number is increasing. So we will do n plus plus. Now next thing we have to do is divide the binary number with 10. Okay, so this was a logic to calculate the converted value of decimal number from binary number, and here we will print the decimal number. Now let's run our code. So if we enter the number which we discussed in example, that is 10, 10 and 10, then we get 42. Okay, if I enter 1 0 and 111, this is the binary number and the converted number is 215. So this was a program for binary to decimal conversion. Thank you.